Now using potentiometer circuit, one can find the internal resistance of the cell. Now see, to find out the internal resistance of the cell, we have to prepare the circuit as shown in the figure. See, A to C, that is potentiometer wire, then rheostat, this is the driving battery, which one is operating the circuit. Then the cell for which you want to find the internal resistance, its positive terminal that we have to connect with. Positive terminal of the potentiometer means with terminal A, which is connected with the battery, B, and of its positive terminal. Now internal resistance of the cell, that is smaller, which is shown in the figure here. Then other terminal, that is with galvanometer to jockey key. Now this particular cell for which you want to find the internal resistance, it is shunted by resistance R. Shunted by resistance R, it implies that parallel to this cell, you have to connect one resistance R as shown in the figure. And with that, one key is also connected. Now first you have to keep this key open. When the key is open, we can say R is not in the circuit. It is open circuited. And now find out the null point. So here, suppose the null point is obtained at position N1 and the length of the potentiometer wire appears to obtain this null point, that is L1. Then we can write the EMF E, that is equal to L1 5. That is the potential difference or potential drop across A and 1. Then after, press this key. Means we can say now the key is closed. So this resistance R is now connected parallel to this cell. So see here, a loop is formed. So in this particular loop, suppose the current I is constituted. So potential difference across this resistance, that is IR, the same will be across two terminal of the cell because this is the parallel combination. And now for this connection, suppose the null point on the potentiometer is obtained at position N2. And the length of the potentiometer wire appears to obtain this null point, that is L2. So we can write the terminal voltage of the cell, that is L2 into 5, because now current is flowing through the cell. So whatever is the potential difference between two terminal of the cell, that is the terminal voltage. So we can write V, that is L2 5. But here we can write V, that is equal to IR also. Now suppose here we take ratio E to V, then simply you can write E by V, that is L1 upon L2. Now what is this current? So that is I equal to E upon R plus R. So we can write E, that is equal to I into R plus R, and terminal voltage V, that is equal to IR, that is the potential difference across resistance also. Now if we substitute these two values of E and V in this particular equation, then E by V, that is I into R plus R upon IR. So I cancel. that is equal to R plus R upon R, and we can write this R plus R upon R, that is equal to L1 upon L2. Now R by R, that is 1, small r upon capital R, that is L1 upon L2. Take this 1 on right hand side. So small r upon capital R, that is equal to L1 by L2 minus 1. Then take this capital R on right hand side. So we will get small r, that is equal to capital R into L1 upon L2 minus 1. So in this way one can find the internal resistance of the cell also. Clear?